In this video, we're going to talk about Lewis structures that can violate the octet rule. Recall that the octet rule says that each element needs to have 8 electrons around it in order to be satisfied in a structure. Well, there's really only 4 elements that need to always obey the octet rule. That's carbon, oxygen, nitrogen, and fluorine. These 4 elements must always have 8 electrons around them no matter what. That is the most important factor when drawing a Lewis structure involving these elements. We've seen hydrogen can violate this rule. It only needs 2. And this is due to the fact that the electrons in hydrogen are in the 1s orbital, which at most can hold 2 electrons. We can consider a molecule like boron trifluoride, for example. And if we were to try and draw the Lewis structure using our normal rules of completing 8 electrons around it, we would find that we always have formal charges surrounding the fluorine atoms and the boron atom. Well, this is not ideal for boron. Boron is okay just having 6 electrons around it. Likewise, aluminum follows a similar suit. Aluminum is okay having 6 electrons. So the 2 elements that are okay having 6 are boron and aluminum. And we have hydrogen with 2. Now, while we can draw a Lewis structure for boron trifluoride involving double bonds, the real structure is that the boron has a single bond to each fluorine atom. So, if filling the octet of a central atom results in a negative charge on the central atom and a positive charge on a more electronegative outer atom, we don't have to satisfy the octet rule. Remember, we're trying to minimize formal charges, and we want to do that by finding the fewest number of atoms with a formal charge on it. Now, anything after including the third row and beyond can violate the octet rule, although it tries to obey it, in that it has empty d orbitals to accommodate more than 8 electrons. In fact, it can hold up to 14 electrons around a central atom if the d orbitals get involved. Phosphorus pentachloride, for example, has 10 electrons around the central atom. Notice each fluorine has 8, but the phosphorus itself is capable of accepting 10. This is due in part to being able to minimize the formal charges of fluorine to be 0, and that of phosphorus as well. We can also have more than 8 electrons in the form of double bonds. The phosphate ion, for example. Phosphate has resonance because we can draw a double bond between one oxygen and the phosphorus in the central to help minimize the formal charges. Yes, there are 3 oxygens with a -1 formal charge on it. However, this is the best Lewis structure we can draw for it. Anything else would cause a positive charge on the phosphorus at the expense of reducing an oxygen with a negative charge. And when we talk about putting negative charges on elements, remember it's always the most electronegative element that's going to have the formal charge.